In this video, we'll continue our discussion of object-oriented programming. We have covered all the material from the Objects 1 notes, and now we're going to start to discuss stuff from the Objects 2 notes. And specifically, that involves making this distinction between instance members and static members of a class. And we'll also look at some other things, for example, having arrays of objects, arrays of instances of a class. Of course, you had arrays of primitive data types that we've looked at before, but now we're going to see arrays of objects. And then also the notion of passing an object as an argument to a method. So all of that stuff is going to be discussed from the Objects 2 notes here. And if we look at the Liang samples, or at least the samples that I had also included, remember I had this package that I called objects, and previously we looked at the simple circle example, which was this one, and then we had the circle class. And now we're going to look at another class called CircleWithStaticVariableAndMethod, and you can see the code right here. And it's being tested or used in this test driver class, test circle with static members. And of course, this one actually has a main method. So this class right here is the one that we expect to instantiate and create instance of. And this is our application, our driver class. Now, there's some similar examples in the textbook in Chapter 9. That you can see. For example, there is this thing that has circle with static members, and there's a test circle with static members, and yes, those are useful, but I preferred to use what was actually in an older version of the textbook, so that's why I have my own examples here. We'll also be looking at something later on, testing of passing objects as arguments. And this total area here will give us an idea of working with arrays of objects. But first we'll delve into the issues of static versus instance variables and methods and see how they differ and when you would want to use one versus the other. We already had a little bit of an idea about that when I talked about when you go to the Java API, and if you see a class where almost everything is static or everything is static, then you know this is not a class that's intended to be instantiated. It's a class that will have methods that you can call. The system class was a classic example of that. The math class was another example of that. But of course, many classes you do intend to create instances of individual objects of this category of this class. The string class was an example of that. And of course, you've already starting to get some experience in building those kinds of classes yourself. So as I said, the stuff that we're covering is still material from Chapter 9, or related to material from Chapter 9. And so let's dive into it. So we have created a class with instance variables before and recalled that there is one variable for each instance of the class. So when an instance is created on the heap, any instance variables for that class are going to be part of the object that is created on the heap. As opposed to class variables, or I should say the variables that will begin with the word static, the static modifier, there's only going to be a single one of those for the entire class, not one for each instance. So these variables will still be variables about the class, but maybe they're more like summary variables. They're more about the class as a whole than they are about each individual instance of the class. And so we'll see an example of that. So they're declared using the static modifier. And you can access them through an instance, like using the name of the variable of the reference variable dot the member name. We saw that in the test simple circle example. Or you can also access them through the class name, and my preference is that you use the class name. If you use class name dot member name syntax, then that makes it very explicit that what we are talking about is in fact a static member. And I'm talking about this whether we're talking about static member variables or static methods. I think that the best way to refer to these from outside the class is to the class name dot member name syntax. Let me give you an example of how you did that with a static method called pow. Which was in the math class. You called it math.pow. You didn't create an instance of the math class and then use that variable .pow. What you did was you just used the class name dot member name. Similarly with system.out. System.out. Well, system is the name of the class, and out is the name of the member variable of that class. I guess it's possible to create an instance of the system class, which I don't know why you would even want to do it, and then use a variable that is referenced in that instance and invoke the static member that way. But that's really not the way that I think is the best way to do it. So from the point of view of programming clarity, if you have a class that has some static members and some instance members, and you want to be accessing from outside the class the static members, then I think the best way to do that is via the class name dot member name syntax. As I say here, class member variables are useful if you want to share the same data across all instances of the class. And we're going to see that, and of course in your next assignment you're going to be doing that as well. Just a reminder, you can use the final modifier to make a constant. So sometimes you have class constants, and these would be both static and final. Something to note about static methods. When we were working with instance methods, including constructors, we saw that they have a this pointer, and that this pointer is pointing at the particular instance for which the method was invoked. Well, there's no such thing as a this pointer in a static method, because a static method isn't called with respect to a specific instance. You cannot access instance members via a static method unless you have either a variable, a local variable that's referencing an instance, or perhaps a parameter that was passed in that's referencing an instance, but there's no this pointer in a static method. The main methods never had a this pointer, and it was certainly not called with respect to any particular instance. So here's our example. Not exactly the same as the listing from Chapter 9, but similar. And the first thing to note is that we, in fact, have this static member variable. So we have an instance member variable, the radius, which you should recall from our previous lecture and examples. So every single circle would have a radius, but we also have this static variable. It's called number of objects, and as we'll see, the point of it is to keep track of, well, how many circles have we created, and we'll see how that was done. So there's our static variable. And you'll notice that there's a static method. And we'll eventually run this, and I'll put a breakpoint here to show you that indeed there's no such thing as a this pointer in the static method. But what this static method can do is access the static member. So this is an accessor method. You can have an accessor method that accesses a private static member, and we see that here. We have a private static member, and this accessor method, if it is static, can also access that static member. Here's a UML diagram that depicts how we illustrate static members. They're underlined. So recall the notation of the UML diagram, class diagram. A class is going to have three parts to it: the name, its attributes or data members, and its operations or methods. And we have private and public here, minus versus plus. And then if it's underlined, that means it's static. So when we do our diagramming, we would want to depict that sort of thing as well. And there's our tester program. And you will notice that in the tester program, they're actually showing you two different ways to call this static method. And here's a method that's called print circle. And you'll notice that this one actually takes as an argument reference to one of these CircleWithStaticVariableAndMethod objects. And you'll notice that, well, they did use the variable to point to the static method. They did use the class name to point to the static method. As I said, I think using the class name makes it more more obvious that this is in fact static. Using the instance, well, was this a static method or was it not a static method? I mean, we wouldn't really know just by using the C variable here. But if it's class name.member name, you know that that member has to be static. So in this code, let's kind of take a look at what the main method is doing. It's creating an instance using the default constructor, and we're going to have a variable called circle1, a local variable of our main method that's going to point to that instance. And then it's displaying some information about that. And it's calling that print circle here, which is going to print the radius, and then also be showing how many objects there are. And then here's another one that's been created using the overloaded constructor, and it looks like we're invoking the mutator setRadius to change the value of it, and then we see what's going to happen as a result of that. And so let's take a look and see what's going to happen as a result of this. So let's start by saying what happens when our application first loads. So keep in mind here that now when we have this class called CircleWithStaticVariableAndMethod, it has a static member variable. So when the application first loads, even before we've created any instances, we haven't created any instances of this CircleWithStaticVariableAndMethod class. Even before we've created any instances, the heap is going to contain all of the static variables of that class. So the way I'm depicting this here is I've got a box, but this is not an instance. This is your static data, okay? And this particular box shows that there is a num of objects variable, and it has been initialized to 0. This is before even anything has been created. The main method has come into existence. It has these two local variables right here, which are going to be references to instances, as we'll see. But we haven't done any instantiation. It's as if we're in the very first statement of main. So again, to get back to the code, it's as if we had a breakpoint right here before we've done any instantiation. So now we get to our first statement in the main method, which is to instantiate one of these CircleWithStaticVariableAndMethod objects. And so we've instantiated it. It's been created. And it's the default constructor. Its frame is going to be placed on top of the stack, as you can see here. It's a default constructor. It has no local variables. It has no parameters. So there's nothing in there with the exception of the this pointer, because remember, a constructor is an instance method, and it was invoked with respect to the particular instance that had just been created by the new keyword. And by the way, notice that nothing has yet gone into circle 1. This constructor has to be invoked before the expression can complete, and therefore before an assignment can take place. So this constructor is invoked. It has a this pointer. The very first thing that happens is that radius is set to 1. As you can see, it's set the member variable. And notice what else happened here. From within the constructor, we actually incremented this value of the static variable. Notice something else. The instance itself does not have a num of objects. There's only one num of objects for the entire class. Each instance will have its own radius, but there's only going to be one num of objects for its entire class. However, point being, it is certainly possible for an instance method to access and manipulate static data within the class. And now, when we get to our second instantiation, we got a whole other instance that's being created here on the heap based on the new keyword. And of course, now, again, the constructor is going to be invoked. This time it's the overloaded constructor because we passed an argument. And so this constructor has, in addition to a this pointer that's pointing at this new object that's been created, it also has the formal parameter new radius, which took a copy of the literal value 5. Even though the literal value was an int, notice that it was automatically converted into a double when it was received here. And once again, we go through the same process. We assign the parameter into radius. So now we have two objects, each with their own radius, and we increment number of objects. And you can see how now what this purpose of this thing is basically to keep track of how many objects were instantiated. And then once that constructor is popped, then the assignment operator can take place. And now we have our local variables in main. Circle 1 is referencing the one object, and circle 2 is referencing the other object as a result of that. So to illustrate this, I'm going to run it first, and we'll see what the results are going to look like, and then we'll use the debugger, and we'll kind of trace through it and look what's happening in memory. So I'm going to go ahead and execute this test circle with static variable and method program, which is going to instantiate a couple of these circles and give us the results. Here's some printouts that are coming out before the circle, creating the circle. This is what we have, circle of radius 1, and there's only one circle object, and then this is also saying there's only one circle object. I'll show you the code for that in a minute. And then after circle 2, we've made some changes, and then after circle 2 has changed to well, we'll see what happens with this circle 2 as a result of creating it and modifying its radius to 9. Here is the print code in here. It was passed as an argument, this reference. And here's where it was specifying what the radius was and calling the get number of objects via the instance, via the reference here. And then here was just calling it via the class name, member name syntax, which, as I said, I think this is a better way to do it when you're invoking static methods. So I'm just going to go ahead and put a bunch of breakpoints in a bunch of places here. I'll put a breakpoint right here where I'm about to instantiate. And then I'll put a breakpoint right here when I'm about to call print circle. So all this is in the main method. And then before another instantiation, and then before setting the radius, and then before the last, when we're about to print circle for circle 1 one more time, and then print circle for circle 2 one more time. And I'll put a breakpoint right here in this print circle method as well. And then within the class itself, maybe put a breakpoint at the beginning of and at the end of each of the constructors, and maybe another one when I invoke this get number of objects right here, so we can take a look and see what's happening. I think that'll probably be enough to illustrate what we're trying to show. And I'm going to debug it now. Let's take a look at what's happening in memory. So here we are. We got main on the stack. We haven't even instantiated or declared this variable. We're about to instantiate and invoke the constructor. So here we go. And here we are in the constructor, which has a this pointer, notice. And so if I expand out onto this pointer, and by the way, that's all it has, right? So this constructor, here we are, its local data is only the this pointer. But if I expand on it, we see that it has a radius. And we also see that it has something static, and that static is number of objects. And if I continue, we have set the radius to be 1, we've incremented number of objects, and we complete the constructor. The frame is going to be popped off the stack, and we're about to do the print here. Now we have circle. We can see that circle now is an instance. It's pointing at an instance. This reference, that would have been the same reference that this pointer was pointing at of the constructor. I expand on it. Here's the radius. Here's its static data. So now we're about to call print circle. We call print circle. And actually we called print circle, and print circle in turn is calling get number of objects. So we see that the frame stack is 3 deep now. If I go to print circle, I can see what print circle has. Print circle has C. Well, what's C? C was what was passed as an argument, which was that very same instance. And we're about to call get number of objects, And we called it this time through C, which is okay, I guess. And so get number of objects is just going to return that number of objects. And now guess what's going to happen? We're about to call get number of objects a second time, because now in print circle we're at this line right here. You can already see what the output has. The output had that first little bit here that resulted from this print line. But now we're in this print line. And in this case, we're invoking it using the class name, which I think is the preferable way to do, as I said. And it's going to give me the same results. And we'll have that. So that shows what happened with print circle that first time we called it. We're about to instantiate our second circle. We're about to invoke the constructor. Here we go again. Now we've got the overloaded constructor on the frame stack. And as I continue, I will have, and by the way, this is pointing at, what is this pointing at? Well, let's take a look. This pointer is pointing at a whole separate object. And that one hasn't yet been initialized. And here's the static. Number of objects is still at 1, but once that takes place, we can see we've done this. A number of objects has increased to 2. So it's not like we had 2 separate number of objects, there was only the one of them. And as we continue, calling the set radius. So let's take a look and see what our circle 1 is going to look like after the set radius. Calling the set radius, and now our circle 1 has a 9. And then we're about to go and do the prints again. And the prints are going to call the get number of objects again. So if I look at get number of objects here, and here's get number of objects, notice that get number of objects does not have a this pointer. Can you see that? Because it's a static method. So all it has access to is the static members, as you can see. And again, it was called a second time for that print. So hopefully you're getting a feel for how this operates and the differences between instance and static member variables. Again, kind of to summarize, if you have a static method, then the only members it can access just without some kind of an explicit reference are static members. If you have an instance method, it can access both instance members because it does have a this pointer pointing to a specific instance, and static members. If you have a static member variable, there's only being one of them for the entire class. If you have instance member variables, there's going to be one for each instance. So the next thing I'm going to discuss is when you have arrays of objects. So in other words, the data type of that array will not be something like double or int or something of that nature. It will be something that is the name of a class. When you have an array of objects, then the elements of that array does not contain data. It contains references to objects on the heap. Kind of similar to when we had a two-dimensional array. Each element of the base array of the first dimension was itself an array, meant a reference to something else that was on the heap. And we saw that when we were looking at the debugger with arrays. So we'll see something similar with that, with objects. So here's the example. Again, this isn't exactly the same as the example from the textbook, but it's similar. Let me go ahead and run it for you. It's basically going to create an array of circles, and it's going to do stuff with that array of circles. So here's the program. It's called TotalArea. It has a main method. It also has, if we look at the navigator here, you can see it has a method called createCircleArray, which is returning a circle array. So it has a return type that's a circle array. There's something else that's called printCircleArray, which takes as an argument a circle array. And then there's also something called sum, which is summing up, looks like all the areas in that array of circles. That's our main class, and it's making use of the circle class, which again, here's the circle class in case you forgot it. It had a private member variable called radius. It had a couple of constructors, and it had a setter and a getter, accessor and a mutator, and then another instance method. And the output of this, if I run it, is going to say something like this, interestingly. It's going to give me, it's going to create a bunch of circles. It's going to print out the radius and the area of each of these circles, and it's going to also give me the total area for all the circles, is what this program is going to do. So let's break that out a little bit. First of all, let's see what happens in main when we have our one local variable of the main method. Of course, we have args, but we have this one local variable of the main method called CircleArea. And when we declared this variable, we are going to have a CircleArea. Now, we haven't created an array. We certainly haven't created any circles, but we have at least created this variable. So now we're about to call this method createCircleArea, which, if you recall, is going to return an array of circle objects, or I should say an array of circle references, each of which would point to an object. And first thing that happens is that, okay, here is our method. Our method has one local variable called CircleArea. It also has this loop counter variable that I'm going to keep track of as we move along, so I kept it there. It's called I. It doesn't really exist yet, right? Because obviously it doesn't exist until we've entered the loop, but I put it in there anyways, just to kind of illustrate. So what's happened here is that we have, in fact, instantiated an array, and that array has a bunch of references. But essentially, these are all null references. If you create any variable that is of a class type, until you instantiate and assign something into it, it's got null. It has a null value. So basically, we have 10 nulls here. And then eventually what's going to happen is that we're going to be in our little loop here. It looks like it's going to be going 10 times. And for each time of the loop, we're instantiating a circle. What are we passing? It looks like we're invoking the overloaded constructor. The overloaded constructor is taking some random number. You can see some random number. Notice again this class name dot member name syntax for calling a method of the math class. We didn't create an instance of the math class. We're using the math class as a whole to invoke its static method called random. So anyways, random gave me a number between 0 and 1. We multiplied it by 100. That was what was passed in as the argument to the constructor. That constructor, of course, was invoked with respect to a particular circle object. That object has just been created on the heap by virtue of this new. So here it does its thing. The assignment takes place. And so now element 0, so I at this point was a 0, element 0 is going to be pointing at this new object. And now another instance is created. And now element 1 is going to be pointing at that object. And then another one, and then another one, until eventually we have 10 elements of this array, each of which is a pointer to a circle object, each of which is a reference to a circle object. So in main, you have a reference to the array, and in each element of the array, you have references to individual circle objects, each with its own radius. So I'm going to put some breakpoints, and let's see what we have here. Here's my main method. I'm going to put a breakpoint right before I call createCircleArea. I'll also put a breakpoint right before I call printCircleArea. Within createCircleArea, I'll put a couple of breakpoints, maybe one here, one inside the loop. Eventually I'll get tired of it and I'll get rid of it, and then with my return statement. And then in my printCircleArea, maybe I'll put a breakpoint right here where I'm about to loop through the array. Maybe I'll put one right here when I'm about to call sum on the CircleArea, and then I'll put another breakpoint here in the sum method, and let's see what happens. So I'm going to debug it. Here we are in main. Here's main. We don't see anything in our variables yet. We're about to invoke createCircleWithArea. We invoke createCircleWithArea. Now we got 2 frames on our stack. Doesn't yet have a circle array yet, but it's gonna. Let me go right into here. Now we got a circle array, an array of circles. We're in our loop. We're about to instantiate our very first one. And notice that circle array has a bunch of nulls, as I said before. And each time you can see new circles have been created. Each circle is going to have some random value in it. And you can see they're being filled incrementally each time in the loop. Let me get rid of this breakpoint. Now we get to the return statement. And at the time of the return statement, every single element of the array is referencing a circle. Each of these are individual circles with their own radius. So we're about to end create circle with array. Now, if I go to main, we still don't see anything because we haven't gotten the return value. And if I go to main where I'm waiting here, where I'm waiting in main is basically right here, where I'm invoking create circle array. So I don't yet have it yet. But as soon as we come back to it, we're about to call print, and there's our circle array, which has all these elements. Now we call the print, and the print goes through. Notice the print took as an argument that same circle array, goes through, does its thing, and notice what it's about to do. It's about to invoke the sum, passing that same circle array, so we're going to be 3 levels deep in our stack. And here we are, 3 levels deep in our stack. And each time it's invoking find area. And remember, find area is an instance method, so it will have a this pointer. In fact, let's take a look at, let me put a breakpoint in find area here. Here's find area. We invoke find area. No, we got to 4 levels deep here in our stack, you'll notice. We got to find area, and if we look at what this pointer is pointing at, it's number 118. If we go back to sum, well, I is 0. What's element number I is pointing to 118. So you can see what's going on in memory with all this. And I think we've explored that enough. So, and then once again, the last thing having to do with the Chapter 9 material has to do with passing objects to methods. We actually did see an example doing this, but let me just illustrate it with the example code here. Test pass object, once again making use of the circle class. And here we're passing the reference as an actual parameter to print arrays. And here it's taking it as a formal parameter. So I think you get the idea with that. So that's all the material from Chapter 9 that I wanted to cover. I would like to address a few points from Chapter 10. There are some interesting examples in Chapter 10, but I think principally the ideas I'd like to get across are some of the things having to do with thinking in terms of object orientation. And one of the topics they come back to is this notion of abstraction. So we saw that notion with method abstraction, where the idea was that all that the user of a method needs to know is its header. You're going to need to know if it's static or if it's an instance method. You're going to need to know what its return type is. You're going to need to know what parameters it expects to receive. You got to have a little bit of an idea of what it's giving you and what it's doing for you. But that's about it. And the same thing applies to classes. Now, classes have more than just the headers of the method. Of course, it also is going to include member variables and things of that nature. A class has a bunch of methods, some of which we want to make public and some we might not. A class might have a bunch of variables, and we might want to make most or maybe all of those variables private and only allow controlled access, as we talked about using visibility modifiers. So this notion of what we keep hidden versus what we provide to the end user is where class abstraction is coming into play. So you can think of the class implementation as like a black box hidden from the client. There is something that you might call the contract, which is the signatures of the methods and whatever public members there are. and the user of the class doesn't need to know how it's implemented. As a matter of fact, we want to keep things from the user of the class sometimes just to protect the data, for example, from being filled with bad values. Another thing that they talk about is some of the things having to do with UML modeling, and they talk about relationships. Now, when you learned ER modeling, you learned all about relationships and the cardinalities of those relationships. So you have a very similar kind of thing going on with classes, and there's three kind of levels to what we think about a relationship, and I suppose you can think of inheritance as being a fourth one on top. I think the inheritance idea is something that will be related to the supertype, subtype kind of idea that you learned in ER modeling. But the things having to do with relationships involving cardinalities, those are basically depicted through these terms right here: association, aggregation, and composition. Well, what's an association? It's a general relationship that describes activity between two classes, and you can kind of get the idea of something like cardinality here. This is basically saying that a student might take any number of courses, and that a course will have somewhere between 5 and 60 students. And we're saying here that a faculty might teach no courses or up to 3, and a course is going to be taught by exactly 1 faculty member. So the notation is not exactly the same as what you see in ER modeling, but the ideas are very similar. Now, some kinds of associations are considered to be a little tighter, if you will, and more restrictive. So an example of that would be a composition. So a composition is a kind of an aggregation. So there's aggregations and there's compositions. And so let's take a look at what aggregation is and what composition is. Aggregation, well, it says here, aggregation models has a relationship. So this is an aggregation right here where there's a relationship between address and student. And what this is basically depicting is that for a given address, you could have anywhere from 1 to 3 students. Here is the aggregation symbol. We talked about the multiplicity, which is kind of like cardinality. So for a given address, you might have anywhere between 1 and 3 students, and each student is going to have exactly 1 name, is what that's saying. And the aggregation is basically saying that this student is going to have an address. So the aggregating class in this case is the student, and the class and the address is the aggregated class. Now, what this is saying is that the name has to belong to the student. The address doesn't have to belong to the student, but the name has to belong to the student. So a composition is a special kind of aggregating relationship where you must have it. And in terms of the coding, we can see that the aggregating class, if we were to go from the depiction shown here, which is our UML diagram, kind of analogous to the ER modeling, and now we go to the coding of the class. The aggregating class is the one that's going to have the member variables of those other classes that are going to be references to these other classes. So keep that in mind when you think about the relationship between what you see in a UML diagram and what you're going to see in your code. Here we see an example that would be similar to a unary relationship in ER modeling, where we have the aggregating class who has a person that is a supervisor. And I'm not really sure that this really makes sense. It seems to me like we should have a supervisor that might have multiple persons. So I'm not really sure that I agree with this figure right here. But the idea being that the person, in this case, is an aggregator that might have other persons. And here we had a situation that if a person has multiple supervisors, we didn't really see a situation where a supervisor might have multiple persons here. There's a lot of other ideas that are talked about in this chapter, but the main other thing that I'd like to just touch on briefly is the notion of wrapper classes. And you will recall that there were 8 primitive data types. And for each primitive data type, there is in fact a class associated with it. So for int, there's a class called integer, and for short, there's a class called short, and for boolean, so for the lowercase b boolean, there's a class called uppercase b boolean, and for the int lowercase, there's a class called integer. And these enable you to do some manipulation involving primitive data types. And the integer class is a nice example of that. For example, one of the things that you can do with an integer class is you can take a string as an argument and try to convert it into an integer using the method parseInt. I do that quite a bit. Or a double, parse double. I do that quite a bit. So there's all kinds of possible things you can do with these wrapper classes, and they come in handy for a lot of purposes. I'm not going to really spend a lot of time with them. So that's all about all the topics that I had to say about Chapter 9 and Chapter 10 material. So we have covered Objects 1 and Objects 2 at this point. The next thing that we're going to start to enter as it relates to object-oriented programming is inheritance, and related to that, polymorphism.